So let's look at problem 2, and it is a line AB 70 mm long, and its end A is 20 mm in front of VP and 45 mm above HP, and end B 55 mm in front of VP and 25 mm above HP. Draw the plan and elevation of the line and find its inclination with HP. So this question is quite similar to problem 1. Only thing, instead of saying the projection on VP and HP, it's given as plan and elevation. Plan is nothing but the top view, and elevation is nothing but the front view. And to do this problem, let's use a help of a small piece of software which we have developed to visualize lines in 3D as well as 2D at the same time. So let's jump to that software. What you see on screen is a software which helps us visualize projection of lines, as I said before. So on the top left hand side, the given data is given, supplied. That is the distance above HP and in front of VP for both ends A and B are given as given in the question, along with the true length, which is 70 mm. So you could see that we are giving 5 different data, and bottom left hand side, what you see here is a representation of the line, this line 70 mm long, which is oriented in a particular orientation with respect to HP and VP, which finally we are going to find out how much it is tilted with respect to HP, which is part of the question. Now the distances, for example, of point A in front of VP is this distance, and above HP is this distance, and similarly for end B, the distance in front of VP is this distance, and above HP is this distance. So we also see that this particular line represents the front view or the elevation of this line, and this represents the top view or plan of the line. So you could see the corresponding 2D view with XY line. This is actually the thing which we'll be constructing as part of our solution, and you could see the corresponding positions A dash, B dash, AB, etc. So this is only to give you an idea how this is going to look like. So this particular software will be very much helpful when we solve problems where lines are positioned in multiple quadrants, so or in quadrants other than the first quadrant. So maybe in the next problem which we'll be seeing, this would be more clear to you. So let's now jump into the actual construction technique. So as usual, we'll start by drawing the XY line. And then we'll position the points A, that is the point above and below XY line, the 45 and 20 mm respectively. And we draw the loci M dash, M dash and MM with the other for the other endpoints, that is for the other endpoint B. So the next step would be to take A dash as center, and with P and B as radius, we draw a line with a length of 70 mm or with a radius of 70 mm. And now we join A dash and A dash. So this is actually the true length which we have drawn, assuming that the line is parallel to EP and inclined to HP alone. And correspondingly, the other corresponding projection will be a horizontal and parallel to XY line, as we have learned. So that we mark as AB. And then as our usual procedure, we will rotate AB with respect to A, and so that it cuts the locus, and that we mark as AB1. Project AB1 back, so to get B1 dash, and join A dash B1 dash. So A dash B1 dash and A B1 are the projections. And finally we'll also find out the inclination with HP, which was part of the question. So we will measure the inclination between the horizontal and the line A dash B dash. So please keep in mind that the length A dash B dash is a true length, and that's why we are taking the inclination of the true length with the XY, which is actually the inclination of the line with HP. And this is quite true because A dash B dash is a projection of the line when it is only inclined to HP and parallel to BP. So that will give the true inclination with the horizontal plane. Suppose the question was to also find the inclination with VP. What we would have done is, as in the previous case, we would have drawn a true length in this side as well, that is in the top view side as well, and we could actually start by keeping A as center and draw another line with the 70 mm radius and cut on this projection, cut on this locus, and that line, if you take the inclination of that line with the horizontal, that inclination will give you the inclination with VP. So this is the same procedure we'll be doing again and again wherever we have questions where we are given the distance from the horizontal and vertical plane for both endpoints, and the true length is given. So for all these cases, or for these kind of problems, this is a typical technique we'll be following to solve the problem. So now let's jump to the next problem. Let's look at problem 3 now. So the question reads like this: a line AB 100 mm long is inclined at 30 degrees to HP, and end A is 15 mm below HP and 20 mm behind VP. The front view measures 75 mm. Draw the top view and its inclination with VP. So this question is slightly different from the last two questions, where the data given are the distances of end A from HP and VP, the true length. So that makes it three different data, or three different values. The other is the inclination of the line with HP, which is given as 30 degrees, and yet another data is the length of the front. So we will also try to see this problem using the software, how this is oriented in 3D, to get an idea of how to draw the projections. Let's see the line in 3D. So we are actually seeing the line AB in 3D view here. So you could see that the line is in the third quadrant here, because from the question it is clear that the end A is actually below HP and behind VP, so that is nothing but the third quadrant. This is a horizontal plane, so below HP will be here and behind VP will be here, so that two coincides in the third quadrant. The line is completely in the third quadrant, so naturally the two things you have to keep in mind is the front view actually will be below XY line. As you see here, this is a front view, so this is XY line, so front view will be here, and since it is in the third quadrant, this is a top view, and you rotate the HP to fall on the plane, so that naturally the top view will become above XY line like this. So this is the top view, this is the front view. So naturally the positions are reversed here. Normally when it is in the first quadrant, the top view will be below and front view will be above XY, but here since it is in the third quadrant, it will be the reverse. So now let's look at how to construct this problem. So as usual, we'll start with the XY line. And we'll start marking A dash and A. You can see that A dash now is below XY and A will be above XY. So we draw the inclination of 30 degrees with XY. So one thing to keep in mind here is that the inclination with HP is given, and naturally the inclination with HP should be seen in the front view, and that's the reason why we are drawing the inclination as shown here. And then with the inclination 30 degrees and the true length, we'll be able to draw the front view. So now the front view which you are drawing is representing the true length, where it is parallel to the VP and inclined to HP. So one more thing I would like to point out here is that the previous cases, when we started drawing the projections, whether it is parallel to VP or parallel to HP, we'll start with one endpoint, say A, and we have the locus of the other endpoint. So what we do is we take the point A, and with that A as center and the radius as the true length, we'll cut it on the locus. But here we do not have any locus, since the data of the other endpoint is not given at all. So instead, the data given is the angle with VP, which will be nothing but the angle with XY line, so which is what we see here. So, and then we draw the true length, which is also given, which is at 100 mm. So with A dash as center, we draw the true length. So now we have completely positioned the other end with this angle and this length. So we are able to locate this particular point here. And we could locate that, and now join the 2 points. So A dash B dash is drawn, which is a front view when it is parallel to VP. Now here, one more thing we know here is that the front view measures 75 mm. So that is another data which we have in the question. So since the front, when you say front view, see, one thing I would like to ask you also to keep in mind is, whenever I say front view multiple times, the front view in this particular problem, or top view in this, but for that matter any problem, will be different for different cases. The initial front view which we have drawn so far, which is A dash B dash, is a front view when it is parallel to VP and inclined to HP. But the 75 mm long front view which we are going to draw is a actual front view when it is inclined to both VP and HP. So that thing we will have to keep in mind. This is a point where many people get confused. So keep on saying front view at one point of time and another, and the problem is differentiating between the front views in each different case. So here the front view we are going to draw now is actually the real front view when it is inclined to both HP and VP. So since already the locus is found by positioning B dash, now we can easily draw B1 dash, which is a real front view. We can easily position it by taking 75 mm radius, which is the length of the top view, length of the front view here, and cutting it on the locus. So that's what we are going to do here. So now that is A dash B1 dash is a front view. And now what we do is we, as usual, we rotate that and make it parallel to the XY line. So what would be the next logical step? So since we have got that A dash B2 dash parallel to XY line, so this is when you will have to connect what we have learned before. The moment you find that one of the views is parallel to the XY line, immediately should strike in your mind that the other view which we are going to draw is going to be a true length, in the other view. So in this case, it is going to be the true length in the top view. So let's proceed. So we project from B2 dash, and naturally we know the true length. So with A as center and 100 mm as radius, we'll cut on that projector. So that point should be B2. So AB2 is a true length when it is inclined to VP and parallel to HP. And one more thing I'd like to highlight here is that the moment you have found one of the views, that is one of the final projections, that is in this case A dash B1 dash, once you find that, one thing you can be clear is that the other view, the point B1 will always lie on the projector connecting B1 dash and B1. So we can directly project B1 dash to the next side, that is other side of XY line, and if you have the other point A, so you can simply join this A and B1 to get the other view. So this is one thing you have to keep in mind as part of the construction technique. So now we join AB2, which is a true length, and we also join AB1, which is actually the top view for the inclined line. So we can find the inclination now. Inclination with VP can be found out by finding the angle between AB2 and XY. So which is 41 degrees. So I would like to once again repeat the whole thing. So we have drawn the started by drawing this A dash B1 dash, then we drawn with an inclination 30 degrees, then we have found the true length, drawn the top view by projecting it back, and from there we found the real top view AB1, and finally we found the inclination with VP. So we'll stop this part of the video here, and we'll proceed on the other set of problems in the next video. Thank you.